Imagine Rajesh, a maintenance engineer starting his shift at a refinery. Before inspecting a pump, he has hundreds of pages of inspection reports, maintenance logs, OEM manuals, safety procedures, and compliance audits. Nobody has time to read all of that before making a decision. Industrial Mind acts like a digital engineer that reads every document, understands it, remembers it, and tells Rajesh only what actually matters. For this prototype, we created the ARC 25 benchmark, a refinery containing 5 industrial assets and 29 engineering documents spanning 6 months. Every uploaded document is automatically classified into one of two categories. Static knowledge includes OEM manuals, SOPs, and regulations. So, how the brain thinks. Whenever a dynamic document arrives, our local Olama model extract structured observation instead of plain text. Each observation contains the asset, the finding, its polarity, confidence, and source authority. HMNN then combines all observation using three signals. First is consensus. Do independent reports agree with each other? Second, momentum. Has this concern been building over time, or is it just a one time event? Third, entropy. Are different sources contradicting each other? These three signals decide how much the industrial brain should change its belief about the asset. If the evidence is strong and consistent, the belief updates significantly. If reports contradict each other, the update becomes very small, preventing false alarm. What appears on the dashboard? After HMNN updates its memory, every asset immediately receives a health score. Healthy equipment stays green, assets showing consistent degradation move into monitor or warning. Unlike a traditional dashboard, this score isn't calculated from a single inspection. It represents everything the system has learned from months of operational history. Ask one single question in English. Now Rajesh doesn't need to search through documents. He simply asks, why is pump 101 under monitoring? Industrial Mind retrieves the asset's current memory, finds the supporting observation, combines them with a relevant manual and regulations, and generate a grounded explanation. Every statement is backed by the original inspection report or maintenance log, so the answer is explainable rather than hallucinated. I'll start the event bus, then we'll check for the connection. We'll go to the web directly, and it's noted here it is connected. Then we'll start the backend also. So we'll start the backend. So here the extraction has been started. So the extraction is done by the large language model Olama. So it processes maintenance logs, inspection reports, operator notes, safety regulations, SOPs, and OEMs manual. Extraction and all the updates have been done by the model, and you can see 29 documents has been processed. So after processing all the documents and all the calculation from the HMNN updates and knowledge graph and drag indexing, you'll see the live health of all the equipments available. As you can see, monitor the health around 50 to 60% is monitor, which has to be monitored, and the green ones are healthy ones. This is the signals from HMNN, which is the equations has been taken from the paper itself. Here are all the documents which are being taken. So the static ones decides what the purpose, and the dynamics one decide what is happening right now. And here it tells about the warning equipment which has to be maintained right now. And simply you can here on the app or on the text dashboard, you can simply ask, why is the pump 101 flagged high as risk? So the language model which will be feeded with all the information and all the available documents will answer based on the calculations. Also here itself he will also answer other questions which the operator will be asking. So this is the basic idea of Industrial Mind backed by HMNN and RAG. Thank you.